All right, good morning. Welcome back to Calculus 2. We are looking at trying to figure out the area between the two curves, x squared plus 2 and 2x plus 5, on the interval 0 through 6. And it tells us there's exactly one intersection point in this interval. Okay, so there's one intersection point. So there's going to be a place where they swap orders. So let's go ahead and see if I'm going to draw a picture first, and then we'll get into the integration and deal with what we have to deal with. Since we're going to go from 0 to 6, I'm going to concentrate on pretty much the first quadrant here. I'm going to call this 2. Okay, so we've got our x squared plus 2, and it's going to look something like this. 2x plus 5, we're going to start up here, and we're going to have pretty much a line that's going to be doing something like that. Okay, so let's go ahead and see exactly where this intersection point actually is, so we can figure out what we're going to do with it. So we're going to say, okay, go ahead and set them equal to each other. So we have x squared plus 2 is equal to 2x plus 5. We'll go ahead and subtract that. So we have x squared minus 2x plus 2 minus 5. I'm just moving everything from the right all the way over to the left equals 0. So we have x squared minus 2x, 2 minus 5 is minus 3 is equal to 0. Okay, and then we're going to go ahead and solve this thing. So we have x minus 3, x plus 1 equals 0. And let's be honest with you guys, the first time I saw this, I was like, oh, did I mess this up? Like, there's two intersection points. Like, well, there is over the whole domain, but since we're restricting this to 0, 6, this guy is out of the question. We don't need this one. So there's only one intersection point between 0 and 6. Okay, thankfully that's going to be that. So what we have to do is we have to break this up into two intervals. We're going to go from a 0 to 3 for area 1 and a 3 to 6 for area 2. Now for area 1, it's pretty clear that x squared plus 2 is a little bit smaller than 2x plus 5. So we're going to say 2x plus 5 minus the quantity of x squared plus 2. Okay, on the other one, we're going to go with a x squared plus 2 minus quantity 2x plus 5. Now we're just going to sort this out. Okay, again, dx. But these are polynomials. They're not going to be terribly difficult to integrate. We just pretty much have to set up our areas and get our geometry right and figure out what's going to happen there. So here we go. We've got 2x plus 5 minus x squared minus 2. That's my first area. Dx, we'll call that area 1. And then we've got our second area, so we have x squared plus 2 minus 2x minus 5, distributing this negative sign to both of them. Okay, and we'll figure this is area 2. All right, let's clean this up a little bit. So we're going to have from 0 to 3. Let's see here. We've got 5 minus 2. Let's call that 3 plus 2x minus x squared. I think that's everybody that's here. Okay, and it's written in ascending form. Not that it matters, it's just it makes it a little bit neater. That's kind of the way you want it. Okay, the next one, we're going to go from 3 to 6. Here we have an x squared minus 2x, and we have a 2 minus 5 minus 3. And now we're in descending form, the x here. Okay, simple matter. We're just going to integrate both of these terms here, both of these integrals, and deal with this. So we've got 3x plus x squared, technically 2x squared over 2, the 2's are going to cancel, minus 1/3 x cubed, going from 0 to 3. Okay, for this piece, we have 1/3 x cubed, minus, again, we have 2x squared, or 2x squared over 2, so we're just going to say minus x squared minus 3x, going from 3 to 6. Now, the hard part of the problem begins. It's the arithmetic. So we've got 3 times 3 plus 3 squared minus 1/3 times 3 cubed. Okay, and we'll go ahead minus 0 because 0 is the other part of this thing. Okay, so we'll go ahead and sort that out. Plus, here we've got 1/3. 6 cubed is going to be 216. Okay, every self-respecting Dungeons and Dragons players know that 6 cubed is 216 minus 36, 6 squared. Okay, minus 3 times 6. And then we're going to have a minus here, and we have 1/3 times 3 cubed. Okay, 27. Let's go ahead and write that as 27. Okay, go ahead and do that. Okay, minus, again, 3 squared is going to be 9, minus 3 times 3. So we've got this going on here. Okay. So I didn't do that much to try to make things pretty or anything like that. I just said, okay, let's just go with what's going to happen. Okay, so here we have 3 times 3 is 9, plus 3 squared, minus, well, 3 cubed is 27. 27 over 3, I believe that's 9. Okay, so we can go ahead and say that. Okay, so this top part here is going to be 9 minus 0, we get 9. Okay, now for this piece here, I'm going to go ahead and say, what is 1/3 of 216? I think it's 72. So I say 216 divided by 3. I'm using my handy dandy TI-30X2, so that's the calculator you guys have access to. So let's see here. I want 216 divided by 3. So we have 72 minus 36 minus 18. Okay. And then we're going to be subtracting from it. Let's see what this is. This is going to be, so we're going to say we have, okay, so we have 72 minus 36 minus 18. I should do that in my head, but, and that's going to be 18. Okay. For the bottom part of this, I'm going to take out the negative sign here for a moment. I'll say minus in a second here. Okay, but 1/3 times 27, again, that's going to be, I believe that's going to be 9. So we have 9 minus 9 minus 9. This is going to cancel. We have a negative 9 here. So we're going to end up with a plus 9. So that's going to be 9 for the first area. And then 18 and 9, which I believe is going to be 27. So we have plus 27, giving me an answer of 36. That's my interval from 0 to 6 of the difference of the area between these two curves. Okay. So with every one of these problems, look for the intersection point. You have to figure out which one's going to be on top, which one's going to be on the bottom, separate them out and go ahead and integrate. If you just carelessly go ahead and integrate between 0 and 6 of two functions, some of that area is going to cancel out and you're going to lose some of it. So it's an important thing to remember to set up the geometry of the problem first, kind of pay attention to, we want this area and this area, but we don't want them to cancel out, okay? So be careful for that. Every one of these problems has a little trick like that, so just be aware that you're going to have to find that, separate them out, and then divide it up into 2 or more regions. Okay? In your case, it's final exam. I left it at 2. Thank you very much for watching the video. I'll see you in the next one. Take care.